Module 4, inflation example 1. We are going to do this in class, but I'm going to go ahead and make a little video of it so you can see how to do it. The example is this: I own a hamburger stand. I want to sell my hamburgers for $7 each. I'm going to sell 500, 750, and 800 hamburgers in each of the next 3 years, but 0 in year 0. If inflation is 2% and my discount rate is 8%, what's the net present value of my sales? And we're going to do this using 2 different options to show you that you will get the same solution. Okay, so I'm just going to set up my cash flows. We're going to sell 500, 750, and 800. My price, let me add a few rows here. I'm going to write option 1 in bold. Alright, my price in time 0 is $7. I have inflation that is 0.2%, and I have a discount rate of 0.08. Make that a little bigger. Okay, so what's the price of the hamburger in the next year? 1 plus inflation. Oops. Times. Okay, so what's our cash flow? It's going to be the number of hamburgers we sell times the price. The present value of the cash flow is going to be that divided by 1 plus the discount rate to the power of the number of years, just like every other discounting problem that we've ever done. And then the net present value is just going to be the sum of these. Okay, so this is option 1. The net present value of our sales is $12,705. Okay, let's do option 2. Alright, the price is just going to be $7 the whole way across. The only thing that's going to change here is we're going to change our discount rate. So the real rate is going to be 1 plus the discount rate divided by 1 plus the inflation rate. I actually don't need to lock those, but whatever. And then I'm going to, just so they're all in the same units, subtract 1, so it's a percent. Notice that the real rate is between the discount rate and the inflation rate, and that's a function of the way that this is constructed. You are essentially doing the same calculation in here, you're just doing it in a way that you don't realize you're doing it. So if the inflation rate is 0, then we get our discount rate back. If the inflation rate is 1%, then we get a real rate that's pretty close to the discount rate. So the larger that inflation is, the closer and closer the real rate gets to 0. In this example, the inflation rate is 2%, so the real rate is about 5.8%. Notice also that if you do the fraction wrong, you will get a negative number here, and that's just a way to check yourself. So you want the real rate between inflation and discount, and it's not negative. That's how you check yourself. Alright, so now that we have that, all we do is just discount like we would any other problem and pretend like there's no inflation. And lo and behold, we get the same answer. So why is that? Why is this cash flow the same as this and this cash flow is the same as this? The answer is you're doing the real rate calculation. In this example right here, you just don't realize it. By inflating the price and then discounting at the at the nominal discount rate, and let me add nominal up here. That kind of screws up the spacing, but whatever. By discounting at the nominal discount rate, you're essentially doing this. You just don't realize it. So on a test, a likely question would be, what is the real rate? And so you'd have to calculate this, and then you'd have to figure out if it should be between the nominal discount rate and inflation. And it is, because it's 5.8%, and that makes total sense because it's going to be between one and the other. So anyway, the answer is they're both the same. Option 1 and 2 yield the same result, and the reason is we're implicitly doing the real rate calculation in this equation. We just don't realize it.